Back in the shop with my first set of geopolymers. So this was the one that I mixed with sand, and it turned out it was very, very dry. So I added a bit of water, but ultimately once I got things mixed up, it set up nicely. So you can see it's got a very shiny surface to it. I didn't do any kind of vibration or anything on it to drive out those air bubbles, so there are a lot of air bubbles in there, but pretty solid stuff. This is the straight geopolymer slurry. So it's got no aggregate in it whatsoever. It's the exact same material that's in this, but this one obviously has the all-purpose sand. And this little experiment here is the same slurry, and I spread it on a piece of canvas, and I just wanted to see if it would stick to the canvas. I mean, obviously it's going to be very brittle, and it's a very thin layer. You can see it's like, I don't know, not even a 1/16 of an inch thick. It's maybe a 32nd of an inch. It's a little bit uneven just because I smoothed it on there and then I spread it over this log. I wanted to see if it would take the shape, so I put it over that log just as something to hold its shape. Obviously this isn't very practical, but what I want to test with this is what this does for the fire resistance of the canvas. So I want to see if it makes this canvas fire resistant. And then the next thing I want to do with canvas is to stretch it onto some kind of armature and then spread a nice even layer and maybe build up a few layers, possibly even alternating with some layers of the canvas. And I want to see if you can create a structure that would effectively have a very organic look to it. Like, imagine if it were stretched out to look like a tent rain fly, and then it had the geopolymer on top of that, and then maybe if you had layers with an outer layer of the canvas, you would still have the texture of the canvas, but it would ultimately be strong enough to hold itself up, as long as it had some kind of an armature providing some actual structure to it. Just an idea. I don't have any idea if it's going to work or not, but just something I'm playing with. But I'm pleased with this. This is the very first batch of geopolymers, and they are only less than 24 hours old at this point, so they're still quite soft. I did cure them in the oven on a warm setting, so I think it was about 160 degrees or so today. But they will continue to get stronger with a little bit of time, and in say 28 days they should be as strong as they're going to possibly get. And then I'll do some tests with boiling and making sure that the structure of the geopolymer is intact. I have ordered some potassium hydroxide and some potassium silicate, and I'm going to try with that because this is a very viscous liquid. And I know potassium silicate is supposed to be quite a bit thinner, so I'm going to try with that as well. And I also ordered some sodium lauryl sulfate, which is also, it's a surfactant. It's what's in shampoos and things that make stuff bubble up. But I read an article, out of a scientific journal, where they used that along with hydrogen peroxide to create foamed geopolymer. So that will be one of my next experiments too. And then ultimately, I need to make a larger batch so I can fill this tray, this mold, and make sort of a scaled down version of my cladding tiles, I guess you'd call them. I'm not sure what you'd call them, but I will make a larger batch, put that in there, mold the first layer, which will be the outer skin, and then mold the foam geopolymer as the inner insulating skin, and I will see how that works. All right, that's it for today.